This video will show you how to balance chemical equations. And to start off, we have this reaction right here. Nitrogen plus hydrogen reacts to form ammonia. So to start off, we can list the number of atoms we have on both sides. So for nitrogen we have 2, and hydrogen we have 2 on this side. But on this side we have 1 nitrogen and 3 hydrogens. So what we need to do to balance this chemical equation is change the coefficients. We can put a number here, but we cannot change these numbers here, the subscripts. So I'm going to start by putting a 2 here. So now we have 2 nitrogens on this side and 6 hydrogens on this side, because we're assuming that there's a subscript of 1 here on the nitrogen. So 2 times 1 is 2, and 2 times 3 is 6. Let's erase that. Okay, but now we need to make up on this side with the hydrogens. So how would we get 6 on this side? Well, we'd have to do 2 times a certain number to get 6, and that number would be 3. So we put a coefficient of 3 here. So now this equation is balanced. Okay, let's try another one. Zinc plus hydrogen chloride reacts to form zinc chloride plus hydrogen. Okay, now we have 1 zinc on this side and 1 on the other side. On this side we have 1 hydrogen, and on the other we have 2. On this side we have 1 chlorine atom, and on this side we have 2 chlorine atoms. So the hydrogen and chlorine atoms are not balanced. So to get 2 hydrogen atoms on this side, we would put the coefficient of 2 here. So now we have 2 hydrogen atoms, which balances with the other side. Now what about the chlorine atoms? So we have 2 on this side, and now since we put the 2 here, 2 times 1 is 2 chlorine atoms. So now both sides are balanced. Okay, now let's try a hard equation. So on this side we have 2 iron atoms. This side we have 1. On this side we have 3 sulfate polyatomic ions. Whereas on this side we have one group of them. On this side we have 1 potassium atom. On this side we have 2, and on this side we have 1 hydroxide, and on this side we have 3. So straight away we can balance out the irons. So we have 2 on this side now, and we can also, now that we've balanced them out, we can try balance out the sulfates. So we can put a 3 here. So now that we have 3 on this side, which balances to the ones on this side, so now those two are balanced out. putting the 2 over here, it changes the hydroxides to six groups of them. So now if we want to balance it on this side, we have to put a coefficient of 6 there. So now we have 6 on this side, and it also changes potassium, so now that we have 6 on this side. And to balance this one, we've already put a 3 here, which changes it to 6. So now that it's all balanced. This side is the same as this side, so now the equation is balanced. Okay, let's try one final example. Aluminium plus iron oxide reacts to form aluminium oxide and iron. We have 1 aluminium on this side, 2 aluminium atoms on this side, so straight away we can see they're unbalanced. 1 iron atom on this side, and also 1 iron atom on this side. 1 oxygen and 3 oxygens on this side. So first, let's start off by balancing out the oxygen atoms. So we can put a 3 here, which on this side we now have 3 oxygens, which balances with the other side. And we also have 3 iron on this side now, since we put this 3 here. So now the ions on both sides are unbalanced, so we will have to add this 3 here, changing the iron atoms on this side to 3, so they're balanced now. And finally we can put a 2 in front of this aluminium, so now both sides are balanced. And yeah, so that's it. This is how you balance chemical equations. Make sure you always add coefficients in front of the symbol, and do not change the subscripts.